Hello everyone. So my name is Satyam Raha, and in this series of videos I'll be explaining the concept of naive Bayes algorithm in machine learning. Okay, so this is a very basic algorithm for classification technique. Okay, and it is probability based. So this naive Bayes, what are the terms mean actually? So Bayes means it will be using the Bayes theorem of statistics or probability, right? And naive means it is a simplistic, there is a simplistic assumption of the Bayes theorem. Okay, so that is why it is naive Bayes algorithm. Okay, Bayes theorem, using the Bayes theorem, it gets a bit complicated when you try to derive the naive Bayes algorithm. So to make it easy, what we do is we actually assume a simplistic assumption, which is the reason why it is called a naive Bayes algorithm, right? So before going into naive Bayes algorithm, I'll have to explain you basic concepts of probability. Number one is conditional probability. So let me show you, tell you the roadmap. So first of all, I'll explain you the concept of conditional probability. Then I'll be talking about the independent events. Then I'll be talking about the mutually exclusive events. Then we'll dive into Bayes theorem. Okay. After that, what we'll do is we'll actually derive the entire naive Bayes algorithm right from the scratch. Okay, to the final derivation of the naive Bayes algorithm, and only after that we'll be going into some very famous example which I have also used for explaining the decision tree. So I will use the data set to find out the final predictions. Okay, to find out the probabilities which are required to do the final predictions. Okay, so this is how I'll be proceeding throughout this series. So let's get started. So see, what is conditional probability? So conditional probability, as you know, is probability of an event A given some event B has already happened. Okay, so again I'll repeat, focus on the English explanation. Okay, so probability of an event A given that another event B has already happened. Okay, so that is equal to probability of A intersection B divided by probability of event B. Okay, this is what conditional probability says, right? So let me take an example. So let's say I have two dices, for example D1 and D2, right? So now, as you know, we have 6 sides on each dice, right? So there are 6 possibilities, 1 to 6. So let's have a question. So what is the probability that dice D2 shows some value, say 4, okay, given D1 plus D2 is less than equal to 5? For example, let's say the question, I'll just model the question. So what is the probability of D2 equals to, let's say 2, okay, given D1 plus D2, that is the summation when taken. See, 2 dices are actually thrown simultaneously. Now there will be some values on those 2 dices. So I'm saying whatever the values are on the dices, so I'll just add them up, and that should be less than equals to 5. Okay, you will get this example in Wikipedia, I guess. So probability of D2 equals to 2, that is on the dice 2 I'm getting 2. What is the probability of that given given that D1 plus D2 is less than equal to 5? Now from this picture, I have done this picture for simplification. You can visualize it. See, on D1 we have 6 possibilities, on D2 we have 6 possibilities, right? 1 to 6. So this is the plus operator. Now 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. Likewise, I have written the entire, this is 6 plus 6 is 12. So these are the all possible sample space. This is the sample space, right? Now what has already happened? D1 plus D2 is less than equal to 5. This has already happened. This is already given, right? So if that is given, so if that is already given, then let me take a light color here. Let's say yellow. So this, so anything to the left of this particular boundary is satisfying. D1 plus D2 is less than equal to 5, isn't it? Anything greater than on the right hand side of this boundary is greater than D1 plus D2 is greater than 5 actually, right? So less than equal to 5, these are the all values, all possibilities, isn't it? Now what I'm asking is, given this is a sample space, what is my probability that D2 equals to 2? That D2 equals to 2. Can you tell me? What will be the answer? The answer is nothing but 3 out of 10. Because you see, how many total values are present? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 possibilities are present. Total 10 is a sample space here. And out of that, only 3 possibilities have D2 equals to 2. So given these entire sample space, what is the probability that D2 equals to 2? It is 3 by 10. Done. Next. This is what we have found it directly. Okay. But using the formula for conditional probability, can we find it out? Let's see. So we already know that probability of D2 equals to 2 given D1 plus D2 less than equals to 5. This is equal to what? This is equal to probability of D2 equals to 2 intersection D1 plus D2 less than equals to 5. This is, let's say this is A, this is event B. Then this is the formula, right? Intersection A intersection B by probability of D1 plus D2 less than equals to 5. Isn't it? This is what my conditional probability says. Definition of conditional probability, right? Now, if we fill this up, what happens? So probability of D2 equals to 2 intersection probability of D1 plus D2 less than equals to 5. What is it? Tell me. So here you look here. So D2 equals to 2 means this entire thing, forget about the yellow color. Just focus on the brown, or rather black, I guess. So focus on this. This is D2 equals to 2. And what is D1 plus D2 less than equals to 5? What is the probability of that? Let's say it is, let's take it. This part. Okay. So what is the probability of D2 equals to 2? It is what? It is this part, and the second part D1 plus D2 less than equal to 5 is this part. Then what is the intersection? What is the intersection? It is only this part is the intersection, right? This part is the intersection. That is 3 out of what? Out of the entire sample space, which is 36. You can see 36 values are present here. Isn't it? So what is the probability? It is only this space, right? Sorry. This is only this space, which is 3 out of 36, right? So this is 3 out of 36. The intersection is only 3. Only 3 values out of entire 36 values. Okay. This time I'll not take the 10 values out of 10 values. No. Because this is the probability of D2 equals to 2 intersection D1 plus D2 less than equals to 5. That means over the entire sample space I am doing this. Okay. That is why I'll have to take 3 out of 36. Now what is the probability of D1 plus D2 less than equals to 5? What is this matrix? What is this part? How many values are there? D1 plus D2 less than equals to 5. It is 10 values. Out of how many values? 36 values. So it is 10 by 36. What is the result? It is 3 by 10. So using conditional probability also, we are getting the same result, okay, as 3 by 10. So it is correct. Okay, so this is how conditional probability actually works. Next, we'll see a concept of independent events. Okay, so see you in the next video. Thank you.